Good morning. I am Dr. Sushmitha, Assistant Professor of Civil Engineering Department, G. Pullareddy Engineering College, Kurnool. In the previous modules, we discussed typical cross-section of permanent way, sleepers, rails, their functions and requirements, and different types of sleepers, sleeper density. So here, in this presentation, we are going to discuss ballast material, different types of ballast material, functions and requirements of ballast, how to improve the subgrade for railway track. So, ballast is a layer of broken stone, gravel or any other type of suitable material which is placed in and around the sleepers, and its main function is to distribute the load from sleepers to the formation below. So coming to functions of ballast, the ballast material is mainly used for load transmission from sleepers to the underlying subgrade formation. So it transfers and distributes the load from sleepers to the larger area of the formation below. It provides effective drainage to the track, railway track, and it helps in protecting the top surface of the formation. The ballast material, it is a suitable foundation for sleepers, and also it holds the sleepers in the correct level and position in order to prevent the displacement by lateral and longitudinal thrust in the railway track. So lateral stability of the track mainly depends on the type of the ballast material. Coming to requirements of ballast material which is used in the railway track, it should be able to withstand hand packing without any disintegration, or it should resist crushing under dynamic loads. It should not make the track dusty or muddy due to powder under dynamic wheel loads. It should be capable of being cleaned to provide good drainage condition, and it should provide resistance to abrasion and weathering action. It should retain its position laterally and longitudinally both. It should not produce any chemical action with rail and metal sleepers. The size of the stone ballast which is used in the railway track, if you use wooden sleepers, it must be 5 centimeters, and it is 4 centimeters when you use metal sleepers in the railway track. The material should be easily workable, and it should be available in the nearby quarries in order to reduce the cost of construction of the railway track. So there are different types of ballast material which are available. So you can use broken stone, gravel or river pebbles or shingle, ashes and cinders, sand, moram, conker, brick ballast, blast furnace slag, and selected earth. So when you consider broken stone, it is the best material that you can use as a ballast material when you construct a railway track, which satisfies all the requirements and specifications of a good ballast, which we specified in the previous slides. So in general, on all important tracks, broken stone ballast has been used. So blast of igneous rocks is the most suitable, and size of the stone ballast should be 5 centimeters if you use wooden sleepers, 4 centimeters for metal sleepers, and 2.5 centimeters for turnouts, points and crossings. So for stability graded stone of size 5.08 to 1.9 centimeters is recommended. So next type of material is gravel. It stands second in the suitability as ballast material in the railway track, which is used in large quantities in most of the countries, which is obtained in general from river beds. Next we have cinders or ashes. So the residue obtained from the coal which is used in locomotives is known as cinder or ash. So it is excellent drainage it has excellent drainage properties because it is very porous in nature. So it is corrosive quality, corrodes steel sleepers and foot of the rails. Next material which you can use as ballast is sand. So it stands fourth in merits as ballast material. It provides a silent track, so there will be no noise when the train is moving with high speed. So great drawback is blowing effect due to vibration of the track. So whenever the train moves fastly with high speed, okay, so the sand material may blow off. Sand gets into moving parts and causes heavy corrosion, so the maintenance of the track is difficult. Coarse sand is better than fine sand when, if at all you want to use sand as ballast material in the railway track. So next is moram. So soft aggregate, it is a soft aggregate. It is a result of decomposition of laterite and has a red and yellow in color. Large quantities of small laterite stone are best for ballast material. So it is recommended as ballast for sidings and main tracks when they are newly laid and not sufficiently consolidated. So next type of material which you can use as ballast material in railway track is concrete. So it is found in the form of particles of varying sizes. So whenever stone is not easily and it is not available at reasonable price, concrete can be used as a road metal and ballast for railway tracks. So for meter gauge and broad gauge, and whenever there is a light traffic, concrete is the most suitable type of the ballast material. So next type of the material is brick ballast. So it is waste from brick industry. So where stone or other type of the suitable ballast is not available, you can use this burnt brick ballast as a ballast material in the railway track. So we have blast furnace slag. It should be hard and high density and free from gas holes. So it is a byproduct in the manufacturing of the pig iron, so which can also be used as a ballast material in the railway track. So these are different types of materials which we can use as ballast material in the railway track construction. So in the typical cross section of the permanent way, we discussed rails main components, that is rails. Next we discussed sleepers and ballast material, and finally we have subgrade material which ultimately receives all the loads which are coming from the rails, sleepers as well as ballast. Okay. So subgrade is naturally occurring soil which is prepared to receive the ballast, sleepers and rails for constructing the railway track. So this prepared surface is also called as formation. So what are the functions of this subgrade or formation? So we are saying that ultimately it receives all the loads which are coming from the rails, sleepers as well as ballast material. So it is the main function of the subgrade or formation in the railway track. So there are some other functions of the formation or subgrade. So they are, it should bear the moving load which is transmitted to it through the ballast with as uniform a reaction as possible. It should prevent the ballast from puncturing into it. It should drain off the water entering from its top. It should provide a smooth, uniform, regular and graded surface on which the ballast and the track may be safely laid. It should not change its volume due to variation in the moisture. So whenever there is changes in the moisture condition, so volumetric changes should not happen in the subgrade or formation. So what are the different methods to improve the soil subgrade? So whenever you are going to provide a railway track in that particular route, first you need to improve the soil subgrade. So what are the different methods to improve the soil subgrade? So we have different methods, that is admixtures of different soils, subdrainage you can provide a blanket, or you can provide a cement grouting, sand, you can do sand piling, and you can provide concrete mats or slabs. Let us see one by one what are these methods. So first we can add admixtures to different soils, so where you are going to provide a railway track. So in this, the desired constituents should be brought from scattered barrow pits and mixed together during the process of spreading on top of the bank before the compaction. So sandy material should be mixed with clayey soils in order to reduce the plasticity of clay soils and provide internal friction. So the best material should be reserved for filling 0.75 to 1 meters of the bank at the top, and the practice should be to use sandy and gravelly material just below the ballast rather than clayey or silty soils. So next method to improve the soil subgrade is subdrainage. So it is useful in specific type of the soils as sandy and gravelly, and it does not help in the case of the clayey or silty soils. So for this method, trenches are excavated longitudinally a few meters beyond the toes of the formation, and also cross trenches at intervals of 15 meters and are connected to longitudinal trenches. So in these trenches, porous pipes known as ticks are laid, and its top a porous material like sand, gravel, etc. is filled, and drains are finally led to natural stream. So next method is blanket method. In this method, a blanket of non-cohesive soil between subgrade and ballast section is used. This will improve the bearing and subgrade properties of the soil material. So next we have concrete mats. Precast concrete mats or slabs have also been used between ballast section and top of the subgrade section. So this is done for ensuring an even distribution of load from the ballast to the formation or subgrade. So here you can observe a concrete mat which is provided under the ballast material and above the subgrade material. Next we have cement grouting. So it is used to stabilize and strengthen the entire subgrade. The ratio of cement to sand which varies from 1:1 to 1:12. And here also in cement grouting we have two types of cement grouting: pneumatic injection and hydraulic injection. So the injection points are placed at 1.5 to 1.8 meters interval in staggered position at both the ends of the sleepers. So next we have sand piling. In this method, a series of holes of 30 centimeters dia are driven with steel instrument inside and outside the rails up to depth of 1.8 to 3 meters, and then it is filled with sharp clean sand and the track is resurfaced. So here you can observe how the holes are made. Thank you.